Hello, this is Vinay Nair from Vichar Vatika, and you are watching the YouTube channel where we share puzzles and a lot of interesting stuff in mathematics. So, here's the second puzzle which we had posted on our WhatsApp channel, and this puzzle is based on a calendar. In fact, this is a great puzzle for parents and teachers to engage with children, especially younger children, because this involves a lot of exploration. So, let's get into the puzzle. We have this calendar of January 2026, and it was the 3rd of January when we posted this. The question was, if you imagine this as a carom board or a billiard board, where you start from 3 and then you hit the ball or the striker along all the odd numbers in a diagonal way, and it bounces off. And of course, as you can see, it bounces and cancels out only odd numbers and not the even numbers. And we see that when it reaches 25, it has nowhere else to bounce, so it's going to get stuck there, or let's say that it gets into the socket. And when this happens, we see that the number 31 is left out. Okay. The question that we are trying to explore is, why is this number 31 left out? And this question why is a very important question in math. We always are interested in knowing why something is happening or why something is not happening. All right. So let's get started. Let's try to start from some other number. Maybe not 3, maybe a different number. Let's say we start from 31 because 31 was missed out in the earlier case. So let's start from 31. We go diagonally. You see that, we get stuck at 25. We are not able to go anywhere, cover anything else. Maybe we should start from a different number, maybe 29. Let's see what happens. Go here, then you get at 25. Again, we are stuck. So maybe not 29, maybe let's try from 25. Then we go in this way, connect all the odd numbers as we go. See that we reach 3, but we miss out 31, right? So why is this happening? We will see this in a moment, but let's try doing this for even numbers and let's see what happens. Maybe we can start with the number 4. Okay, we start from 4, we go diagonally, the ball keeps hitting all the even numbers, it bounces off on the edges, goes in this way. That's it. We are able to cover all the even numbers, right? And in this process, we are not retracing our step. We are not lifting our pen, and it's just like how a billiard ball or a carom striker would strike off or bounce off on all the edges. So it works from 4. Good. Maybe God favors even numbers. Let's see. Maybe let's start from some other even number and see if it works. Let's say we start from 24, go to 8, and then goes to 26, 18, 6, goes all the way up to 30. Oh no. Come back to 24, and then there are so many even numbers left, and we are not able to cover that. Maybe that wasn't the best place to start. Let's start from 2. Let's see what happens. Go to 26, go this way. All right, seems to be working. We reach back 8, and then we'll be on the same track. It is not working, right? So it seems from the initial experiments that for even numbers, it works from 4, but it does not work from at least many other even numbers. Well, let's try to think, why is this happening? Why is it that we are able to do it from 4, and for odd numbers, we aren't able to do it from any numbers? So to understand this or to explore this, what I'm going to do is I'm going to put some numbers here. I'm going to place a 1 at 3, and 1 at 31, and 1 at 25. Now, what I mean by this 1 is there is one way to come to 25, there is one way to come to 31, there is one way to come to 3, right? Which means 25 can be a starting point or an ending point. 31 and 3 also can be starting points or ending points. Okay, if you look at all the other odd numbers, 5 has 2, there are 2 roads that go into 5. 7 has 2 roads that go, in fact 3 that go into 7, right? 15 has 4. So every other odd number has more than 1, or in fact all the other odd numbers have even degree. This is what we call as degree of a number, let us say, and this degree is the number of roads or number of ways that are that exist to reach that particular number, right? So we see that for 25, 31 and 3 the degree is 1, which means if 25 is a starting point, then 31 or 3 have to be the ending point. But then you can have only one starting point and one ending point. So what happens to the third one? The third one is naturally left out. And this is the reason why we were not able to cover 31, 25 and some numbers, right? So if we have a calendar like this where you're having more than 2 odd degree numbers, then it is impossible to cover that using this carom board or a billiard bouncing thing. Okay, all right, let's move on. Let's try for the even numbers. So for 4 the degree is 1 because there is one road that comes into 4. For 2 it is 2. For 10 it is 2. For 24 it is 2. For 30 it is 2. Similarly, if you look at 14, it is 4, right? Because there are 4 roads, so you will see that 12, 14, 16 are 4. 22 is 4. 20 is 4. 18, 26, 28 are all 2. 6 is 2. 8 is 3 because there are 3 roads, right? All right. So if you think about this problem, you will see that you are able to, if you start from 4, you are exiting 4 and you don't have to come back to 4, right? So 4 in this case is our best choice to start or end. Why? Because if you start from some other place, let's say 10, okay, and you go all the way, let's say you from 10 you go to something else, maybe you just take it, yeah. So 10 you go here and then you go there and then you go this way, you go all the way. Well, in this case, okay, we are able to complete everything, but we don't know whether that will always happen. And here maybe, yeah, so I think we have messed up here, because from here it has to go to 8 and only then it can bounce off somewhere. But in this case again 28 is left out and something else is left out, 4 is left out, right? So it's always very good to start from a vertex or a number which has an odd degree, and in this case you can see that 4 has an odd degree and it has a degree of 1, which means it has to be an ending point or a starting point. So let's start from there and then things become easier. Okay, all right, so that was the reason why it was working for even numbers and not for odd numbers. If you have children who are very young, or if you are a math enthusiast, if you are a teacher, look at the calendars every month and see what will happen if you start from a particular day. So let's say today is the 11th of January. You can see what will happen if I do this on 11th of January. Will I be able to complete everything, or will there be some numbers that are left out, or maybe I should take a different route and then that will help me achieve all the numbers, or maybe not. So we can look for all these dates, and maybe we can call these days as lucky days of the month. from where you can start and you can do a complete tour of all the even numbers or odd numbers. Okay, so I hope you will have a lot of fun with this and keep exploring this. And by the way, this topic is from a very interesting branch of mathematics called graph theory. That is what we have essentially used to argue or to reason why it works for 4 and why it does not work for 3, 25, and 31. Right? So the reasoning is coming from the branch of mathematics called graph theory, where we deal with something called as vertices and edges. So vertices are, imagine they are people, and edges are connections between people. As people know each other, maybe there is an edge, and if people don't know each other, maybe there is no edge. So this branch of graph theory was, this branch called graph theory was brought out, or rather invented, by the great mathematician Euler. He had to solve a problem, the seven bridges problem, the famous Königsberg problem, and he thought that with the existing branches of mathematics, I'm not able to tackle that. So what better way than just to invent a new branch of mathematics? Cool, huh? So that's what he did. And you can try if you can create this pentagon with all diagonals without lifting your pen and retracing your step. You can also try this particular figure. Is it possible to start and end without lifting your pen or retracing your step? And whether it works for from every vertex, whether it works from every point, or are there only specific points from where it works? Okay, and then you can try to bring in the odd degree and even degree aspect and see how you can explore this further and whether you can have a more logical approach to solve this problem. All right, so if you like this problem and if you're interested in more such puzzles, subscribe to our WhatsApp channel of Vichar Vatika and also this YouTube channel, and you'll keep getting more and more such puzzles with which you can learn more and more stuff in mathematics.